So we have the function. First off, we need to find the derivative. So the derivative is going to be, the derivative is going to be equal to x minus 2. The derivative is going to be x minus 2.
So sir, if we didn't write that it's a derivative,
you need to get into the habit of writing that.
Yes, I did. I'm just asking with that.
You're not going to lose a point, but you're going to get into the habit of writing that. Otherwise, I might start taking points.
Are you not to do dy over dx?
Yep. Yep. So next up, we need to find the value of the derivative when x equals minus 1. So we've got minus 1 minus 2 equals minus 3.
Wait, but sir, it doesn't say derivative, it says f.
Oh, shit.
Yeah, I didn't do for the derivative.
No, but it does. It says it here. So, sorry. It says find the gradient. It says find the gradient of the graph y equals f of x at x equals minus 1. That means you find f dash of minus 1. It says it very clearly. It says find the gradient. It doesn't say find the value. If it said find the value, you find f of minus 1. If it says find the gradient, you find f dash of minus 1.
So y equals fx is the same thing as y f dash x?
Y equals what?
Because there it says y equals fx and x equals minus 1.
Yeah, if you want, okay, I'll explain. So what it's requiring is f is a function which will transform any set of numbers to a different set of numbers. When you apply f to the domain x, it will generate another set of numbers, f of x. Now, if you wish to graph that on a coordinate axis, you're graphing x against y is equal to f of x. And that's what this statement here is saying. It's saying graph these. This is talking about the curve, which is created by drawing the collection of the domain and range of this function. Don't worry about the details. It's math teaching. So we need to find the equation. So in order to find this equation, what have we got so far? We don't have the y value. So we need to find the y value. So y is equal to f of 1, minus 1. We put minus 1 in here, we're going to get a half minus plus 2 plus 3, which is going to give us 5, 10, 11 over 2. You can write this one as 5.5 if you're doing it on your graphing calculator, but you're going to want a fractional that makes it easier for you. So next up, we need to aim for finding the function. So we use the 1 point formula, y minus 11 over 2 is equal to, we got the gradient here, minus 3, x minus, and it's minus 1, so plus 1. Put it into the 1 point formula. You got a 2 there, so move the 2 around. You've got 2y minus 11 is equal to minus 6x minus 6. Rearrange everything so we get 6x here plus 2y, and then we have to add 5 to both sides, so minus 5 is equal to 0. So any integer multiples of that will be accepted as the correct answer.
Was 2 supposed to be squared?
Yeah, so the answer is 9 over 2 for the y.
Go to the original function? Yeah, it's x squared. So you do 2 squared, so it's 4.
On this question, x is minus 1. So here, when you're finding the y value, you were looking for y of minus 1. You've got a half bracket minus 1 squared minus 2 bracket minus 1 plus 3.
That's 9 over 2.
Minus 1 squared is 1. Minus 1 squared is 1. 1 times a half is a half. That's why I have a half here. Minus 1 times minus 2 is plus 2. plus 3 is still plus 3. So we have here 5.5. 5.5. 5.5 is 11 over 2. This is the answer. Okay, so here we have another function. We do the same question again. We start off with a. We need to find the derivative. So f prime of x is equal to 2x minus 2 over x squared. Do this in one step. We need to find the equation of the line. So there's a few bits and pieces we need to do this. We need to find the gradient. So to start off we need to find f dash of, what's our point? F dash of 2. We've got 2 bracket 2 minus 2 over 2 squared. This is going to give us 4 minus 2 over 4, which is 3.5, which as a fraction is 7 over 2.
Is that a 4 in the first number?
Sorry, let me answer one question at a time.
Where did the square come
From the derivative of,
from?
so we have x squared plus 2x to the minus 1. So if we find the derivative of this, we get 2 times 1 minus 2x to the minus 2.
Those write it as a fraction 2 over x to the minus 2.
That's right, it's a fraction. It's easier for the arithmetic.
It's in question B, the answer is the first number is 4.
Yeah, I
Four like minus over 4.
That's a 4.
Oh, sorry.
Okay, so we found the y, the gradient, but on this question, it wants us to find the normal. So if we find the gradient of the normal, that's going to be the perpendicular, the reciprocal, negative reciprocal of that.
Why did it say perpendicular?
It says here, find the equation of the normal. The normal is perpendicular to the tangent. So we have minus 2 over 7. So what else do we need? We're going to need the y value. We're going to need y1, which is equal to f of 2. We put this into the original function. We're going to have 2 squared, which is 4, plus 2 over 2. So that's going to be equal to 5. We put all of these values into the 1-point formula. We've got y minus 5 is equal to minus 2 over 7, bracket x minus 2. We've got a 7 in the denominator there, so let's multiply through by the 7. We get 7y minus 35 is equal to minus 2x plus 4. Rearrange everything to one side, making the x positive. We get 2x plus 7y is minus 39 is equal to 0. This is the correct answer.